Hi ladies and gentlemen, I hope everyone is doing well today. Today we are taking a look at using moles with formulas. This video is going to be part one. This was a longer chem class, so I did decide to break it up into two parts for us to make it a little bit more manageable. So right up front we are taking a look at percent composition. So percent composition tells us the percentage of mass by an element in the compound. So the example they use is sodium chloride. The percent composition would tell us how much sodium we have or how much chlorine we would have in a given sample. So what we would use is this formula. This is a formula you are going to have to memorize. I did highlight it in blue or make a blue square around it so it's easy to read. So remember the percent composition of element X will equal the mass of X of 1 mole of that divided by the mass of 1 mole of the compound times 100. I know it sounds confusing, but remember all masses, whenever we have 1 mole of something, it is found on the periodic table. So all you have to do is look it up. So next, it provides two examples. So the first example, we find the percent composition of calcium and calcium chloride, CaCl2. So we just rewrite the formula a little bit. The formula in blue is very generic. It uses element X. Down here where it says element X, we substitute our elements. So we're looking at the percent composition of calcium. So we're looking up here is the mass of calcium. Down here we're looking for the mass of calcium chloride. So then if we look at the next line, we have our masses substituted. Remember the mass on the top is the mass for calcium found from your periodic table. The mass on the bottom is the mass of calcium chloride. I highlighted it for you. Remember this little 2 in the formula comes from the subscript for chlorine and CaCl2. We have to multiply by 2 because we have 2 chlorines. Then all you have to do is plug this into your calculator. Remember to do the division before you multiply by 100 when you solve your percent. The next example it uses is calcium. We're finding the percent composition of nitrogen and calcium nitride, which is right here, Ca3N2. So one thing I want to remind you is really important. Remember, nitrogen is diatomic. Remember, diatomic molecules are very reactive. They don't want to be alone, so they react with themselves. So whenever we're finding the mass for nitrogen, any of the ones that are diatomic, so remember Brinkelhoff, we use N2, not N. That is why we have a mass of 28. We would have to multiply the 14 by 2. Very important to remember, any of your Brinkelhoff are diatomic. Any of those you will have to multiply the mass by 2. Then again, the mass on the bottom is just the mass of the compound calcium nitride multiplied by the subscripts found on the periodic table. Then we divide. Remember to divide before you multiply, then you solve for the percentage. Again, you can just type that into your calculator. Really the most important thing to remember from this example is your diatomic molecules. Remember to use the mass of 2 of them. They're so reactive. They want to bind with themselves before they are alone. So then next down here, we need to verify the the percent composition of carbon is 82.6 in C4H10. So I highlight some information that they provided for you. So for the mass of carbon, we get to use 12. For the mass of hydrogen, we get to use 1.01. These masses were given, but they are always found on the periodic table. Remember, you can just look there. So I rewrote the formula for us. Where it says element X, I plugged in carbon. So remember, we have the percent of mass of carbon equals the mass of carbon. Remember, I included the subscript 4 over the mass of the compound, C4H10 times 100. Down here, I solved for the masses. Remember, it tells us to use 12 for the mass of carbon, so 12 times 4 is 48. Next, we do the same thing. We find for the mass of the compound, C4H10. We multiply 4 times 12 because we have 4 carbons. Then we multiply 10 times 1.01 because we have 10 hydrogens. Remember, it tells us the mass of hydrogen up here, 1.01. That equals 58.1. Next, we just plug our numbers in. 48 divided by 58.5, 58.1 times 100, it comes out to 82.6%. Remember, when we verify, we just have to make sure that the percents match up. So this is how you solve the percent composition. Next, what I want you to try to do, now in question 2, I want you guys to solve for the percent composition. I did set up the formula for us. So remember, the percent composition of sodium will equal the mass of sodium. Remember the one we want in question, we have Na2. Remember, we use the formula for sodium sulfide is Na2S. So you have to do 2 sodiums. and then on the bottom is the mass of the compound, Na2S. Remember, we multiply all that by 100. Remember, all of your masses are found on the periodic table. When you are using masses, if they are not given to you and you are finding them on the periodic table, do not round them. You have to use all the decimal places to make sure you get accurate numbers. Next we have a table of some compounds. All of these compounds are hydrocarbons. Remember, hydrocarbons are always made of carbon and hydrogen, just different amounts. So I already helped you out a little bit. I filled in the molecular formulas. So all you would do, if anyone's curious, is you would count up the carbons, add up the hydrogens, and then that's how you get the formulas. Next, you're going to use the percent composition formula to calculate the percent composition of hydrogen and the percent composition of carbon for each one. That's question 4. Question 3 is asking us to verify the values for hexene. So I am going to show you how to do that. I do want to remind you that you can use the mass of 12 for carbon and the mass of 1.01 for hydrogen. So we're looking at question 3, so we are looking at the ones that are given to us, hexene C6H12, so I will write that here so we remember what the formula is, C6H12. So we are looking at the percent composition of carbon, so remember that would be the mass of carbon, we have 6 of them, over the mass of, I wrote that wrong, C6H12. Next, we will plug our values in. So remember the mass of carbon. So we would multiply by 6 times 12. I highlighted all the subscripts for us. So this is the subscript for carbon. This is the subscript for hydrogen. We multiply times by 100. We add. It comes out to 85.6. We do see that it is 85.6 up here. One thing I want to remind you guys. Remember, all percents are out of 100, so we can subtract from 100 to find the missing value. So instead of doing all of this work again, you can just subtract from 100 because there's only one left. So if we're finding the percent composition of hydrogen, we can do 100 minus 85.6, which would give us 14.4%. That's a percent sign. I had to squeeze it in. So then again, we can verify 14.4%. So next, when you are solving these next couple of problems, you can use the work that I've already done. So remember, these are hydrocarbons. So what's not highlighted, the masses will never change because the mass of carbon and the mass of hydrogen never changes. But what does change are the subscripts. I did highlight all the subscripts for you. So when you are solving for propene, benzene, cyclobutadiene, you can just solve for the percent of carbon by changing the subscripts, and then you can solve for the percent of hydrogen by subtracting from 100. Remember, you can subtract from 100 because all percents are out of 100 and you're only missing one of them. So that is a quick, easy way to solve for these. So remember, just change the subscripts and then plug them into your calculator. That's question 4. Question 5, 6, and 7. Those are kind of some theoretical questions. We have talked about percent composition, empirical and molecular formulas a little bit, what it's starting to get at now. So I think you can answer those questions. What I do want to talk about is number 8. So number 8 is asking you to try to think about the percent composition of hydrogen and the percent composition of carbon for these two formulas without using your calculator. I think you guys can do this because you already found a bunch of percent compositions in that table. What I want you guys to focus on is the ratio. So remember the ratio of carbon to hydrogen in each of these. If we looked at the ratio of the first one is 1 to 1. The ratio of the second one is 1 to 2. I want you to compare those ratios to the ratios you see in the table. Which values or which molecular formulas in the table have the same ratios? Do you think those percent compositions will be the same? That will help you fill in the table. Last section in part 1 is the empirical formula. So remember, the empirical formula is the formula that describes the lowest whole number ratio of elements in a compound. So that's why we're starting to look at the ratios again. So question 9. Question 9 is asking us for the empirical formula of composition, which has a percent composition of carbon 92.2% and a percent composition of hydrogen 7.8%. So you need to think about the ratios. Remember, ratios can be reduced. So what you need to think about, what is the reduced ratio of carbon to hydrogen when the percent composition is 92.2% carbon and the percent composition is 7.8% hydrogen? I guarantee you, if you look back at this table, table 1, you will find values of percent compositions of those values, and look at the ratio. What is the ratio of the empirical formula? Remember, empirical formula is the most reduced. So once you find that, reduce the formula. Question 10. So question 10 is verify that the empirical formula for hexene is CH2. So remember, ratios can be reduced. Remember, if you're too lazy to look back at table 1, which you shouldn't be because you've been flipping back and forth, the formula for hexene is C6H12. What does that reduce to? That will help you. Remember, if you have any questions from this chemquest, please circle them, write your question down, ask me when you come to class. Hope everyone has a good day.